Okay, so here's the finished product of highlighting, and you can see it makes it a lot easier to see. And so one of the first things I usually look at is I kind of put aside the traits where only one organism has it or where all the organisms have it, because those aren't super informative. So like trait 4 has only one individual that has it, so we're just going to sort of put a line through it for now. Trait 5, everybody has it. So we'll just, trait 8, put a line through these that aren't very informative. Trait 12, trait 13, trait 16. Okay. All right, so then we just need to start making groups. So trait 1, both C and E share that trait. So it's a good indication that maybe C and E form a group together. All right, so that's trait 1. Trait 2 indicates that maybe A and F are together. So this was trait 1. Trait 2 says A and F might be together as a clade, okay? And then we go to trait 3. Oh, trait 3 is uninformative also. Trait 4 is uninformative. Trait 5 is uninformative. Trait 6 has everybody together. Let's come back to that one. So we've done trait 1, we've done trait 2. Let's look at trait 7. Trait 7 says that B, C, D, E, and G. So we have C and E already. So let's go ahead and include B, D, and G. So we know that these guys were together, but B, D, and G are now together with all of them as one big happy clade. All right, and that was from trait 7. Okay, so now we have that kind of a grouping. So then we go to trait 8, uninformative. Trait 9 says C and E, so we already know that. So trait 9 confirms that. Trait 10 says C, D, E, and G. So C, D, E, and G are actually a clade. So I'm going to put a little bracket in here indicating that these guys, independent of our little CE grouping and our B grouping, those guys, C, D, E, and G, according to trait 10, look like they might be together. So this is a trait 10 thing. All right. Trait 11 says D and G. So look, D and G are actually a group in and of themselves. So let's put a little thing there. That's number 11. Number 12, uninformative. 13, uninformative. 14 groups B, C, D, E, and G again. So B, C, D, E, and G. That is 14. So 7 and 14 confirm that same relationship. Okay. 15 says A and F are together, which we already knew. So 2 and 15 both confirm that relationship. Trait 17 is everybody but the out group. So all of these guys, same thing. Okay. Oops, I forgot a little highlight there. Same thing as trait 6, so we're going to come back to those. All right. So let's see, we've done trait 7, we've done trait 9, we've done 10, we've done 11, we've done 14, we've done 15. Okay, 17 we'll come back to with trait 6. 18 says C, D, E, and G. So C, D, E, and G. So that same one as before, the little brackets that we had with 10 is also 18. Confirms that as well. 19 says C and E, so same as we saw here. 20 says D and G, so same thing as 11 said. Okay, 21 groups are B, C, D, E, and G again, so all of these guys, so same thing with 7 and 14, so 21. 22 is everybody but the out group, so same as 17 and 6. And then 23 says B and F. Well, that doesn't really match what we're seeing. So let's just put that off to the side for a moment. B and F, trait 23 says. All right, so from here, we can actually draw a tree because we can see the relationships. We've done trait 21, 20, 19, 18, and 23. All right, so we can put a big bracket for all of them together except the out group. And that was which traits? Trait 6 says that. Trait, all but the out group. Trait 17 says that. Trait 22 says that. All right. Okay, so now that we have this, we can actually draw a tree. So I'm going to bring this out just a little bit so you can see. We draw the tree. Okay, so we know that D and G are together as a clade. And we know that C and E are together as a clade. Okay, I'm going to make a little thing out here. So what trait said that D and G are together? That was 11 and 20. Right? What trait said that C and E were together? 1, 9, and 19. Okay, now anything group these four together? Well, yeah, 10 and 18 grouped those four together. So we're going to go ahead and group these four together and say that 10 and 18 did that. Okay, and then outside of that is B. So let's just put B outside of that. And what traits grouped all of these guys together? So we have 7, 14, and 21. Okay. And then we have A and F in there. So A and F are outside of that group. What things grouped A and F together? 2 and 15 did. What things grouped A and F with the rest of them? Okay, well that was all these guys, 6, 17, and 22. And actually this guy should be right here. But B and F are this funny thing out here. 23 is sort of a funny thing. Now we could rearrange our whole tree to make trait 23 fit, or we could say, 23 might be something that evolved twice on the tree. That's convergent evolution or analogy. And so we're going to put 23 right here and on F. Because there's no way to reconcile it with the rest of the tree. And that's okay. Okay, I think in the DNA matrix there's also one that doesn't really reconcile. And then we have our out group that's outside, so we'll just put him out here. And were there any traits that everybody had? Yeah, so trait 5. So let's go ahead and put trait 5 on the tree. And then our uninformative traits, we can go back and look at them. So ones that only had, let me back up a little, ones that only had one thing, so like trait 3 was only an A, so we can put it only in A. Okay, trait 4 was only in the out group. Trait 8 was only in C. Trait 12 was only in G. Trait 13 was only in B. Trait 16 was only in F. Where did I do that? Okay, and so we've got our tree finished. Let me zoom in a little bit. The only thing you don't know, let me go pull up my key. The only thing you don't know is about trait 4. We don't really know if trait 4 evolved in the out group as a 1 or if it was there prior and then everybody else lost it. So trait 4 could go either way. It either went to a 1 to a 0 right here or went to a 0 to a 1 right here. And either way is fine. And it's the same thing with the DNA matrix. All right. So once you've got that, we do have a few traits that are a few terms that we need to introduce here, okay? And really these should be introduced in the actual lecture. So my bad, I should have, when we were talking about what a node is and what a clade is, we should have talked about these three terms. So a monophyletic clade is a clade that includes everybody from the common ancestor. So they have to circle a monophyletic clade that includes at least 3 species. So they just have to include, so if I chose to do A and F and the next one over B, I'd have to include everybody that comes from that common ancestor. Or I could do everybody that comes from this common ancestor, which would be B, E, C, G, and D. Or I could do everybody that comes from this common ancestor, which would be D, G, C, and E, etc. Okay? Identify a homology for species A and F. So a homology is a trait that defines everything beyond that point. Okay, so A and F, anything along here or there, the most appropriate ones would be these homologies right here. So 2 and 15 define A and F. And then the last thing says identify convergent evolution. So that's that trait 23, right, that shows up twice on the tree. That's a convergence. So both species B and species F evolved trait 23 independently. All right? And it's the same thing with the DNA matrix. You're just going to highlight everybody that had A's or everybody that had C's. Now the one key with the DNA matrix is just like here where we assume the outgroup is 0, you're going to assume that the outgroup is whatever it was before. So if the outgroup has an A on the DNA matrix, then that's going to be, then everybody who's different from A and the same as each other, you're going to highlight. All right, so it's a little more challenging, but you've got a key. And if you have troubles with it, please do ask me. And that's it, folks.